I'm Jay from MLDA at EEE, and today is the third day of our AI Research Student Conference 2021, and we start by the keynote speech by Dr. Wee Hyong Tok. So first of all, I'd like to introduce about our organizer, MLDA at EEE. So MLDA at EEE is a student organization in NTU that aims to provide an integrated platform for EEE and IM students to learn and implement machine learning, data science, and AI, as well as facilitate connections with the industry. So during the past years, MLDA at EEE has conducted many workshops and collaborate many industry projects for the students in EEE and IEM to get exposure to machine learning and data science. And now I will introduce our today's keynote speaker, Dr. Wee Hyong Tok. So Dr. Wee Hyong Tok is a principal data science manager with the AI CTO office at Microsoft, where he leads the engineering and data science team for the AI for Earth program. Dr. Wee Hyong has worn many hats in his career, including developer, program and product manager, data scientist, researcher, and strategist. And his track record of leading successful engineers and data science teams has given him unique superpowers to be a trusted AI advisor to customers. And Dr. Wee Hyong also has co-authored several books on artificial intelligence, including predictive analytics using Azure machine learning and doing data science with SQL Server. So I believe we will be inspired and will learn a lot from Dr. Wee Hyong. So Dr. Wee Hyong, please take over the presentation now.
Yeah, and I'm going to start sharing my screen as well. Thank you, Jie, for the kind introduction. See whether you all can see the screen.
Yeah.
Sounds good. Give me a moment. Just making sure I have everything I need. Okay. So I think first of all, thank you for the opportunity, right, to do this sharing and also deliver the day 3 keynote. And looking at the kind of AI activities that's happening in Singapore, it warms my heart. Every time I hear about, whether it's recently in the news, in Channel News Asia, where they're using AI to monitor some of the data, right, that's coming from the CCTV cameras at the MRT stations and so on and so forth. So that's really exciting. And I think when I was reflecting and preparing for the talk, I decided to call the talk Humans and AI, because I felt like every time we have an AI topic, often we talk about the technology, we talk about the kind of huge advancement that has happened in the field for the past many, many years. But I think the key to AI is really the people and the humans at the center of it, right? And today, for example, we see passionate people from different walks of life, and they're using AI to not just solve commercial problems, but they're also using AI to tackle some of our social as well as environmental toughest challenges. And I felt like it's important for us to put people at the center of all AI innovation and solving challenges that we face today, right? And I think the potential of AI combined with a lot of the ideas from a group like this, as well as the broader Singapore community, as well as the broader global community, it will have that transformative power for us to leave a positive impact on the world and the people. And so today for this keynote, I'm going to structure it on 3 areas. We're going to start off with acceleration and ML, and we're going to look back at what has happened in the field since many years ago, but also bring us back to the present and talk about some of this AI at scale work that's happening across various technology companies as well as research institutions. I'm going to share a lot of these examples from projects that I've worked on, but at the same time also projects that's been worked on by many of my colleagues across the company, just to show you, what are the art of the possible. And then we're going to end off the talk just focusing on AI for good. Right, so before we start off even with acceleration in ML, we just remember we started off with, this is a keynote about humans and AI. And so we're going to start off with how AI is being applied today by just showing you a video. this is really an app that we built together with a French company, and the app's name is called Help Picto, and it provides a really innovative solution to help children with autism communicate with the environment, with their parents, and with people that's around them. And to help them stay focused, a child with autism usually use very specific pictograms, if you will, in a sequence to be able to recognize a situation, or answer a question, or interact with people. And Helptico is actually one of the applications that we built together with a French software company in order to use speech to text to generate a sentence. But more importantly, it uses language understanding to categorize some of the keywords with a final objective there to build a sequence that represents a specific situation. And of course, helping one of the person that you'll see in this video. So without further ado, I'm going to play the video.
Arthur, c'est un autiste sévère qui n'a pas de langage et qui a 15 ans.
Pour aider les personnes avec autisme à communiquer, il y a des images. Donc ça peut être des photos, des pictogrammes.
Le classeur, le PEC, c'est pas quelque chose d'évident, de facile. On n'a jamais la bonne carte. La bonne carte, elle est perdue, elle est tombée sous le fauteuil. D'où l'intérêt pour lui de communiquer avec El Picto.
Le départ d'El Picto, c'est des discussions que j'ai eues avec Karine, qui avait une idée depuis quelques temps, mais c'est devenu possible depuis quelques mois. Microsoft a développé ce qu'on appelle des cognitive services, mis à disposition dans le cloud, et qui vont permettre d'exploiter des choses qui étaient très difficilement exploitables auparavant. De la reconnaissance d'images, de la reconnaissance vocale et des traducteurs automatiques de langue. Et ça, c'est important parce que c'est nous donner la possibilité à nous, PME, d'accéder à ce qui se fait de mieux en matière d'intelligence artificielle.
Je parle, je donne une information à Arthur et elle est traduite par l'application El Picto instantanément en pictogramme et après d'une façon orale.
Va t'habiller et te brosser les dents.
Ce qui est intéressant, c'est qu'il y a une interface qui va ensuite transiter dans tous les milieux de vie de la personne. Ça permet de développer de l'autonomie personnelle, de l'autonomie domestique, participer à des tâches. C'est un outil qui est évolutif.
On a eu la chance d'organiser avec Microsoft un Helpfest, une sorte d'hackathon où pendant 3 jours, on a été immergé dans une salle de réunion où on a fait quasiment 24 heures non-stop de développement. On y est rentré avec une idée, on en est sorti avec une solution. On est une petite société, on a 40 ingénieurs qui travaillent sur plein de domaines divers et variés. Il nous faudrait des années pour pouvoir construire une solution identique. Aujourd'hui, on a besoin d'une architecture qui est la plus petite possible avec le coût le plus bas possible. Donc on s'appuie sur Azure pour ça et faire en sorte que demain, quand on va atteindre des centaines, des milliers d'utilisateurs, j'espère, on puisse juste appuyer sur le bouton et puis augmenter la charge serveur, la ressource disponible d'un claquement de doigts. Plus on utilise El Picto, mieux ça fonctionne. Le modèle va continuer à apprendre au fur et à mesure pour faire en sorte de l'optimiser et de le spécialiser.
On va pouvoir remettre en place une communication qui est plus spontanée. Donc en termes de qualité de vie, ça c'est absolument énorme. Je crois que ça aide à recréer du lien.
C'est beaucoup plus ludique, plus facile, comprend mieux. Ça paraît pas grand-chose, mais en fait c'est énorme cette différence. C'est vraiment énorme.
Now, so I think you see from this video, right, how AI is making an impact to many people around the world. And I felt like, us as AI practitioners or aspiring AI practitioners, we have this opportunity to change the world, right? And so let's bring back to the some of the things that have happened. And for many of you that might have been following some of the local tech scene, many years ago, you would have seen, many of us participating in this competition called the Micro Mouse competition. And of course, this kind of nature of competition has evolved over the years, where you have this little robot. And of course, on the chip there, you had burned a program into it that was very primitive form of AI years ago. And the goal of this robot is to navigate a maze, right? And of course, today, as we look back at, a lot of this competition that has happened, you will have seen that this is AI at its very beginning, right? And so right now here you see one of the winners for an earlier competition many years ago. And he has this little robot which is called the Micro Mouse. And he put it into the maze. And just observe how fast it finds its goal, right? And there's exploration, exploitation, but continuously learning, right? Before it gets more fast second, which is like amazing. And if we look at a competition like this, and if you fast forward today, now in all areas of machine learning, whether it's speech translation, NLP, computer vision, reinforcement learning, there is tremendous acceleration in machine learning. And I felt like we are at an amazing time today. Us as a community, whether you're in school, you're in the commercial world, if you will, I think together we can actually make a huge difference, leveraging some of this acceleration that make it all possible. And I felt like, the time is right for us to be able to leverage a lot of this to create a lot of innovative application. And if you reflect back and look at the whole space of machine learning, right, there is really 3 dimensions to it. At least that's how I see it. There is, of course, innovation that's happening in algorithms. Now, so in academia, for example, whether it's ICML, CVPR, and many of these other conferences that's happening, every single year, the amount of algorithms that has been made possible, new algorithms, improvement in existing algorithms, and the speed in which you can achieve quality result is just like breathtaking. Hardware acceleration continues to make tremendous improvement. And of course, infrastructure that's enabled not just on a box, whether it's your laptop, all the way to the public cloud, tremendous progress has been made, right? And of course, on hardware, whether it's getting some of these models to be able to run on CPU using accelerated inferencing, leveraging GPUs and tons of GPUs, is just amazing. And of course, FPGA and ASIC continue to be a really active area of work among many of the technology companies that's out there. And if you look at the space of AI or machine learning models, right, we all know, for example, in the space of NLP, Hugging Face has been making tremendous progress in making pre-built models, language models available for you to use today. And if you reflect years ago, whether it's availability of model zoos for computer vision related application, whether it's image classification or object detection, you see similar trends happening on pre-built models. And of course, for a lot of the industry that we need to work with today, pre-built models will only get us that far. It gives us a good foundations, but it's so important to then be able to then customize this and be able to customize this in a way that suits the specific domain that you're working against. And so if you look at the whole space of machine learning, whether it's classical machine learning or deep learning, as we said, right, there's tremendous progress. And just to give you a sense of the tremendous progress that's been made, and this is probably just a subset of it that we've been tracking for a while, right? Whether it's from vision all the way to language understanding, every single year, the pace of AI advancement is just increasing. From getting to object recognition and achieving human parity, all the way till and here I only show up to 2019. 2020 was an amazing year where there's tremendous progress that's been made, just not enough to fit into the slide. In all these areas, whether it's translation, speech recognition, understanding, in the context of reading comprehension, all this has achieved human parity, right? And this is extremely exciting. Now, and to just make it more tangible, what you see here is a question, and feel free to think about it. How long does it take to train a deep neural network? And one of the many times when I show a slide like this, many of you would say, well, the data scientist that's in you or the ML engineer that's in you, this is not the right way to ask a scientific question because it's too vague, right? So rather the question here is, how long does it take to train ResNet 50, which is a kind of deep convolution neural net architecture, on a data set called the Imagenet? And of course, Imagenet, since it was released, it has changed the world of computer vision. And just to put things in perspective, training ResNet 50 on Imagenet, and here I only show again up to 2019, right? It has gone from days to hours to less than 2 minutes. And what is also important here is, of course, you could say, well, these are all the big companies, whether it's Facebook, all the way to Tencent, to Fujitsu, leveraging huge amount of GPU resources, minus the one from UC Berkeley that uses Xeon CPUs. But I think the point that we're trying to get here is not only tech companies or large research institution with the kind of resources to bear can do this feat, right? And what has happened since then is, and this was a thing that we took at a snapshot in 2019, and C2 runs, for example, some of the AI meetups in Singapore. And a while back, of course, he shared that in 2019, he trained ResNet 50 on Imagenet from scratch at about $21 US. Just imagine, right? Using GPUs that are readily available in the cloud and using the PyTorch framework. But what he did not share in this, besides the training course, is he finished training, right, in less than 2 hours. Now, that's amazing because it means all of us can do it. And I'm sure many of you back in school, in grad school, you have access to quite a lot of this kind of resources. It means all of us can do it today, which is super exciting. Now, if you reflect on this, it's not just about computer vision. The same kind of things that you saw acceleration in computer vision is happening in NLP, right? And here, of course, this was a really nice picture provided by some of the folks that you see there on some of the recent advancement in language model. And what has happened since then is the following. Language models are getting larger and larger, and this was adapted and credits to the Distilbert article for writing about it, right? From Elmo earlier, all the way to the Megatron LM model by NVIDIA, which is about 8.3 billion. And then, of course, if you continue moving forward, you have Distilbert, which is at 66 million parameters. And you think that the world would have paused and stopped at that point in time. But what has happened since then is models are getting larger and larger, right? So in February 2020, last year, we announced a 17 billion parameter language model, which is fascinating. And if you even fast forward a few months later, we announced again, huge advancement made in May, where we did a 10-time increase or 10x improvements on the amount of parameters that can be supported in a language model. And what has happened since then is OpenAI, right, in July 2020 came out with GPT-3. And of course, many of us have started playing with GPT-3, which is 175 billion. Now, if you continue fast forward to today, January 2021, Google announced the Switch Transformer, which is about 1 trillion parameters, slightly less. And in April this year, in fact, just about a month ago, we announced improvements and innovation made in this thing called a zero infinity optimizer that not only allows you to achieve 1 trillion, in fact, it's much more than 1 trillion on paper. And of course, all this needs to be eventually tested on huge hardware that's possible. And so whether it's computer vision, whether it's NLP, and many, many of the other fields in machine learning, this acceleration is just amazing. And what is also interesting is, well, we say, well, you know, these are huge models. I'll never be able to use them because storing it is going to be a problem. Many of the companies out there have started making available these models available to you as APIs, which means if you're looking at creating a startup or you're looking at advancing the state of art, you can already write on the strong foundation that's made by all these giants that's out there. And so we talk about the innovation in computer vision, we talk about the innovation in language or NLP in general. Let's bring all this together. So the next thing I'm going to show you is how we brought computer vision, speech, translation, and more importantly, a really top of mind topic, which is mixed reality, all into one, and just to show you a glimpse of what kind of future, right, we're looking at. So let me play the video.
What if technology could help me be anywhere I needed to be and speak any language I wanted? Well, it can. We are bringing together the power of mixed reality and Azure AI services to create a truly game-changing experience. What you're about to see is an exact hologram of me wearing the same outfit that we recently captured at a mixed reality studio. And I don't speak Japanese, but what if I wanted to deliver my keynote in Japanese? Using Azure AI technology, I can translate my English into Japanese and train it to sound exactly like me, the same voice tones, those same inflections. Now we brought this together, my hologram and Azure AI, to show you what's possible. So first, I'm going to put on my HoloLens 2 here, and then we'll flip in the room to the special camera so you can see exactly what I'm seeing. Let's get started. First, let me introduce you to Mini-Me. There she is, my perfect holograph. And thanks to the power of HoloLens 2, she just floats right with me. I'm literally holding my hologram, so natural. Now she's a little small to do a keynote. So let's get her up so she can do full-size Japanese keynote. Render keynote.
ホログラムになることには本当に驚くべきことがあります。私たちは最新の複合現実キャプチャ技術を使用し、私のホログラムを作成しています。実在の人物をホログラムとして見たことがあるかもしれませんが、私が実際に日本語を話しているのが新しいのです。私は日本語を話しませんが、私の声とホログラムは完璧な日本語で話しています。これはニューラルテキスト読み上げと呼ばれる最新の人工知能技術、いわゆるニューラル TTS を使用しています。
So what you saw, right, was really us bringing all this technology coming together, right? And of course, today I can't show it to you live just because we're not doing this in person. This was something that we showcased close to about 1.5 years ago. And of course, technology has progressed tremendously since then. But it shows you how, not just us being able to deal with mixed reality, but being able to do translation, right? And more importantly, be able to then articulate some of this translated Japanese text in the voice of Julia, who is the lady that you see in the video, right? By leveraging a lot of this personalized text-to-speech technology that we have been working on for a long time. And bringing all this together and making sure that the mixed reality version of her, right, is able to talk about and deliver the same keynote for her in the context of Japanese in her voice, right, which is super powerful. Now, and what is all this technology that you're seeing here in this video is not even futuristic or, like something we created just for a demo. This technology is available today, right? Which means all of us can actually build similar kind of capabilities in applications that we could build, like hackathons or even for commercial application or even for research. Now, super amazing. And so next, what I'm going to talk about is really, we talk about the acceleration in machine learning. I gave you some examples of why keeping the human at the center of AI is so important. And now I'm going to transition, right, to talk about AI at scale project that's happening at Microsoft. And of course, before we get into the specific, this is really a big thank you to all the teams across Microsoft, right, for making all this possible. And the first project that I'm going to talk about is Project Turing. And one of the goals of Project Turing is to make machines literate. And of course, here you could see some of the work and some of the papers that are written if you go msturing.org. And what Project Turing is doing is the Turing team developed some of the state-of-art large-scale models to solve some of the challenging problems that's happening across Microsoft, from Bing to Office, to Xbox, to Dynamics. And the mission of the Turing team is to expand the boundaries of natural language understanding, machine learning or machine reading comprehension, question answering, being able to transfer learning or apply transfer learning for NLP problems, and even leveraging reinforcement learning approaches, computer vision, and even working towards building interpretable models. And so, of course, the mission of the group, right, is huge. And I just want to show you some of the early success that you might already be experiencing it today. And all this underneath the hood is powered by Bing. And for each one of these examples that I'm going to show here, you will actually be able to read about it. There are papers that's written about it as well. And so we start off with some of the AI at scale effort at Bing, enabled by Turing. So here, if you look at it, in the past, if you go Bing and you say, can dogs eat chocolate? On the left, what you see is the before. This is the kind of results that were written. Of course, it's a combination of, leveraging information retrieval techniques, but also being able to leverage a lot of these NLP techniques in order to get you this initial result. Now, with the progress made in the large language models that I was showing you earlier, today, if you go Bing and search for this, not only can you give you the chunk of text, it can give you the answer, right? Which is essentially, if you map it back to an NLP problem, it's a question answering problem and more. And on top of that, we also provide you with some of the sources where these answers are teased out from, which will then give you more kind of deeper reading just to understand why did Bing tell you that can dogs eat chocolate. Now that is super powerful, and this is just the tip of the iceberg. Now the other example that I wanted to show is Microsoft Word. Many of us use Word today, or we might have used Outlook as well. And of course, one of the things that is important as you type, whether it's in Outlook or whether it's in Word, is to be able to have smart replies, things that is very actionable, things that will help you improve your productivity. Now in Excel, today in Excel, you will also have this notion of ideas. And if you click on ideas, you could then ask them natural language question. And underneath the hood, of course, a huge amount of both language model as well as computer vision model comes into play to be able to not only give you the answer based on the data that you have in Excel, but also to give you the chart that you could then bring it back and insert back into Excel. Now, one of the things that I did not cover here is PowerPoint as well. In fact, preparing for a presentation like this, today PowerPoint, deep inside PowerPoint, you could turn on Presentation Coach, which will tell me, how well am I doing rehearsing for the presentation, which are the kind of words that I use very frequently, or maybe I should use them less frequently and give you a score. And it helps you become a better presenter. Now, all this leverages a lot of this advancement in large language models that we saw earlier. So that puts things in perspective. Now, Microsoft 365, whether you're using OneDrive, SharePoint, you will see actually now we get better summaries. And this is extremely powerful, right, for us to navigate the huge amount of information overload that we have today. And on the right, of course, you see the earlier model that we have and some of the Turing-based models that is now giving much clearer and much more concise result. Now, super powerful. Now, this is just like a glimpse of products that we use every day, of which many of the work by the Turing team, as well as a lot of the language models that you saw earlier, right, are in action. And these are not just prototypes that was developed. These are powering the 1 billion or more Office users that's using Office products globally. And so what we did not cover here is then with such large language models, how do you deploy them to production at this kind of global scale? And also making sure that, you never get into a situation, whether it's in PowerPoint, OneDrive, SharePoint, when your latency is causing you to have a bad experience with the product. Now, to be able to put all this kind of plumbing together, where operationalization of AI models is super important and lots of thoughts goes into the engineering aspect of it. And so kudos to the team for doing it. Now, but the next natural question that most people would ask would be, with such large language model, how do you train them? And just to put things in perspective, today, if you take any model, whether it's a deep learning model or any other models, if you have even up to 1.3 billion parameters, this model itself is not going to fit into a single GPU. Now, today, of course, there's tremendous progress made in GPU hardware, right? But today, one of the state of art for GPU is it has on board about at most 32 gig of memory. Of course, and this is still increasing. So this is one reflection. Now, the other thing that's interesting is every time I put this slide up, and for some of these keynotes that I deliver, you'll realize that I'll probably be able to use this slide for n other keynotes. Not true. Every time I prepare for a keynote like this, I will have to update it. So first, I updated it from 17 billion to 117 billion. And just specifically for this keynote, for this conference, I have to revise it again to 1 trillion. Now, I'm sure, a few months later, if I deliver the next keynote, I'll probably be updating the slide another time, and trillion is just too small. And I think the point I'm trying to get to is in order for us to be able to train a trillion parameter language model or any deep learning models for that matter, significant amount of innovations needs to happen that will enable you not to just use the GPU, but be able to fuse together your GPU, CPU, and any kind of memories that's available. That's one piece. But two is to make sure that you have amazing push, right, on the utilization of all this compute resource, if you will. And three is to ensure that the overheads of passing some of the parameter values are reduced to the bare minimum, because otherwise you will hit a point of diminishing return. And so this is exactly what we did with the Turing team, which is we announced DeepSpeed.ai, and this is actually a snapshot up to 0.2, which then allows you to train this kind of trillion level parameters, but being able to leverage the enhanced memory footprint across all the hardware that you have. And as you're executing it, being able to help you proactively reduce the memory footprint on, you know, how you handle the gradients, how you deal with your activation memory, or how you even deal with a practical situation of memory fragmentation, right? And one other thing that we did is we open source this, meaning today, all of us have access to this technology, right, to push the state-of-art model, because we truly believe that if we were to open source this, then every one of us as AI practitioners and every one of us, whether we are in the research community or commercial community, we can now continuously push the state-of-art. Very, very powerful, right? And this just shows you, you know, the memory usage before you use DeepSpeed together with the zero optimizer. Without the zero optimizer, today you would easily have maxed out all your GPU, assuming your code is written well. Now with the zero optimizer, you realize that the GPU utilization is actually kept to the bare minimum, meaning you can push more to the GPU. But more importantly, for all the code that you write, we actually require you to do very little changes in order to take advantage of DeepSpeed and zero. Now, which is another huge innovation, because if you have to rewrite a whole chunk of your code to take advantage of something like DeepSpeed and zero, then we have failed, because then we just made the problem even more complex than it already is, right? And so zero as the optimizer has two sets of optimization. One which we call zero DP. This is aimed at reducing the memory footprint of the state of the model. And the other one is really what we call zero R, and you can read about it all in the paper, which is targeted towards reducing the what we call the residual memory consumption, right? And this itself has been allowing us to train models that are larger and larger as we speak. Now, this just shows you, you know, some of the analysis that we did on why the zero memory optimization allows us to work towards training of trillion parameter models. Again, the paper is provided. It's a really new paper that, you know, if you're in this area, I encourage everyone to read it. And this just shows you, you know, the progress that we made, whether it's the scale of the parameter and also the speed in which we can train this model, right? And more importantly, us being able to achieve super linear speed up, which is really amazing. And of course, up to 13 billion without any kind of model, whether it's model parallelism technique, etc. We allow you to do that, right, on very standard GPUs, which is amazing. Now, fast forward to today in April, we announced zero infinity. Every time, you know, when we talk about zero infinity, I always remember to infinity and beyond. If you all recall that statement by one of the movies. And now zero infinity is, of course, enabling us to not just achieve 3D parallelism for some of the 3D models, whether it is from the number of parameters that we can achieve to the throughput that can be achieved, is just amazing, right? And here you can see how we achieve this on 1 terabyte parameters on a single GPU. And this allows us to go from 10 trillion to 100 trillion parameters. And we have not even, I think this is just the tip of the iceberg, right? There's still tremendous opportunity that's out there. And from an efficiency perspective, right, being able to achieve about close to 50 teraflops per V100 GPU is amazing, right? And so this is something that we have just published recently in April this year, and we encourage everyone to check it out. Now, the next project I wanted to share is really Project Natick. And Project Natick was really a project that me and my team, together with the principal PI for Natick, worked together on when it was first launched several years ago. And Natick was really our first attempt to launch a data center underwater, right? So what you see here is at the beginning of the Natick project, where we put the data center underwater. And I still remember that day when they launched it, Ben, who is the principal investigator for the project, gave me a call. And he said, hey, there is all these cameras that's outside this data center I just launched that is now submerging underwater. And I go, what? And he said, yeah, it's true. I just put a data center underwater. And I have all these camera feeds. You guys are the AI for Earth guy. Tell me what you want to do with it. That was essentially the question he gave me. And of course, we spent close to several days frantically trying to label the data that he gave us, both day and night data, in order for him to track the kind of marine ecosystem, whether it's fishes, whether it is arrowworm that move really fast, and then being able to count this over time to understand the impact of us launching a data center underwater. Super exciting. Now, fast forward 6 to 9 months later, in fact, around the world, whether it is in Australia or in Europe, we partner a lot of the Microsoft partners to leverage similar kind of technology. In this case, it was our joint work with ABB, right, to be able to measure the size and the weight of the salmon fish in this kind of farms that are in Europe. Now, super powerful. And so I gave you a sense of, the acceleration in machine learning. I talked about some of the projects that we've been working on and how we have applied it in products that we're shipping today. I think I wanted to close off with two thoughts. One is to make all this possible, data is really the fuel for AI. Now, without data, we will never been able to train all this model. And so one of the things that we did is, and as AI practitioners, many of us will know, is data is always scarce. You might not always get the data that you need for a lot of the situations that you are in. And so, of course, we work with, for example, the Microsoft AirSim team to be able to generate synthetic data that are realistic, that obey all the physics law, if you will, right? In this case, this is us leveraging AirSim to generate the visual footage from a drone, right? And so this same code we have run on this simulation, this same code we have run on an actual drone, right? And then being able to use this data as a way to train our machine learning models. And what you see on the bottom is really one, the infrared view, and the other one is the segmentation view of things. Super powerful. Now, the other thing that we did is together the HoloLens team is in order for us to build, like, the experience that you're seeing earlier on with HoloLens, we need a lot of synthetic training data to understand how do we understand that this is a hand, what is the hand doing, and so on and so forth. And so we work with a lot of computer graphics researchers as well, right, to generate synthetic training data that are labeled images, but leveraging a lot of advancement in the computer graphics area. And why use synthetic data is because they give you very clean labels without annotation, noise, or error. And you can generate it in all sorts of conditions, right, that you otherwise would have spent a lot of effort annotating by hand. And last is you have this control on the variation of data set, super powerful. Now, the next slide I'm going to show you is essentially, this is us generating synthetic data for the HoloLens 2. And here, of course, you see, the synthetic hand in the 3D space, right? And what you see in the bottom is the different kinds of views, including the synthetic labeled data that we're generating. Now, all this has allowed us to make tremendous progress in how we think about machine learning models in something like HoloLens 2 and more. And this just shows you synthetic data for us to solve a very practical task of hand tracking, from the visible light spectrum, RGB, to the depth camera, to generating the ground truth for machine learning. And we've actually been applying this not just for HoloLens 2, but similar technology in many, many other commercial applications. Some of this I can't share publicly today, right? And this video is essentially another exciting area of work, also not just on synthetic data, but part of our autonomous system work. And what you see here is essentially a DARPA challenge on how can you get a vehicle that you see there to navigate a subterranean like this, right? And so right now you're actually seeing the camera view from that vehicle all running autonomously through this subterranean. And that, of course, a DARPA challenge that happened about 1 and 2 years ago. Right, and the DARPA Sub-T challenge aspire to further technologies that will augment very difficult operations underground. And of course, the challenge to all technology teams is how can you do this autonomously, which is really amazing. So I think with that, I'm going to end off this keynote, right, by talking about AI for good, and we're going to go through it really quickly. And I felt with a lot of gratitude, right, to all the AI for Good team across Microsoft on us working together, including a lot of the non-profit grantees that we work with in leveraging AI and, more importantly, technology and resources to bear in order to empower all these organizations, right, to solve some of these really fun but also tough global challenges, whether it's on the environment, whether it's about humanitarian issues, accessibility, health, and cultural heritage. And of course, health took on a different spotlight just because of the COVID situation that's happening globally since last year. AI for Earth, this is a program that I'm extremely proud of for co-founding the AI for Earth data science and engineering team. We started this work several years ago, and today the aspiration there is to build this planetary computer that is going to connect the global environment network, right, and enabling anyone that wants to tap all this environment data to leverage this in order for us to come together to advance some of the sustainability efforts globally. As part of this program, there's a lot of grants available. In fact, NTU and many of the organizations in Singapore, they've applied for the grant and they're part of the AI for Earth grantee program. Super exciting. Now, the other program that we've been doing a lot, we started AI for Health way before COVID, but it turns out that COVID has created, a situation where we diverted a lot of the AI for Health resources, right, to work with the global scientific community on not just supporting response to COVID-19, but working together to unlock some of the innovations that is possible, right? And so this is super exciting as well. AI for accessibility, what you see on the right is an app that we built called Seeing.ai that's using AI to help a lot of the people, right, to be able to, that has low vision, to be able to understand the world and navigate the world. And of course, besides that, there's a whole bunch of other programs with a goal of using AI and technology to make the world more inclusive and accessible. Now, AI for Humanitarian Action supports a lot of the solutions for the vulnerable communities and people in the world. And each one of this program comes with its grants that anyone globally can apply for. Very, very exciting. The last one is AI for Cultural Heritage. We started off this talk by talking about humans and AI. And I think one important thing here is to all of us, whether we're in Singapore, whether in the US, whether in Europe or any part of the world, I think our culture, our language, and our history, right, is so important. And if we could use technology and AI to be able to not just preserve and enrich a lot of this cultural heritage, whether it's through language translation, revitalizing language that might not be as mainstream, this will be something that we can make a tremendous impact on the world. And so I'll end off with our effort on creating a planetary computer. And in fact, this planetary computer today, a lot of the bits and pieces are available for everyone, right, to, apply as a grantee, but leveraging some of the resources that we have to bear in order to create this interconnected environmental network of data and tools. And so, if you're interested, definitely visit the website that you see below as a way to get access to some of these resources. And so I think with that, thank you for, spending close to about 45 minutes of your time on the keynote, right? And, listening to how us coming together can truly change the world, keeping humans or people at the center of everything that we do for AI projects. And so I'll hand it back to TAE as well as Jiafei for any questions and answers. Thank you.
Thank you, Dr. Hyong, for your excellent speech. And I believe our viewers have learned a lot from your talk. So now we have a few questions from them. First of all, one viewer asked, as models getting bigger, but chips will not always keep getting smaller, will we eventually reach a limit? Does it mean that it's a next AI winter?
I think, and I'll answer that question very carefully. One is when we did the 17 billion parameters for a language model, we think that we have already hit the limits, right? But as we saw, every few months, we do 10 times and 10 times more. And so I think we are not even hitting any of the limits as per today, given the advancement in algorithms, hardware, and infrastructure. But there has been a lot of effort within the research community, as many of you know, which argues against large language models. And they've been looking at ways of getting these large language models to be distilled down to be smaller models without sacrificing the accuracy. Some of these approaches, right, would be the teacher-student approaches. If you look at what has been happening in the NLP community, you have the BERT model, but that started all of this. And, just a while later, the distilled BERT model came along, right, that allows you to have the same power as BERT, but then using less parameters. So I think several things will definitely happen. I don't think we are at the tip. We have not hit the limits. Large language models will continue to be even larger, but all these efforts around distilling the models into smaller models, I think is also going to make tremendous progress as well. And three is there's been also a lot of work on trying to do very specialized chips to be able to run these models, right? And so all this combined together will help us advance the state of art. Mm-hmm.
Thank you for the answer. I hope this answered the viewer's question. And next, another person asks, does small parameters necessarily mean improvement? And I have read a paper about GPT-3 memorizing training data.
Yeah. No, that was actually a really nice paper. And many times we also talk about some of the biasness in the models, right? Not just for language models, but also for computer vision models. I think how to deal with biasness in model and how to deal with situations like memorization of data is a clear and present challenge that we all have to deal with together as a community. And there's been a lot of work, like here we have an approach which we call fair learn, that's trying to reduce the biasness in some of the models that are trained. And I think with such large language models, there's also other kind of discussions around, does it really mean that your models need to get larger and larger and larger in order for it to be more powerful? I don't think any one of us has a good answer there yet. But it does seem that as the models gets larger, it seems to be able to deal with a lot of the more real-world practical situation, keeping biasness in mind. And I've seen people use GPT-3 for a whole range of things. Recently, one of the efforts was translating from any programming language to any target programming language. And I think if we use it in the right way, then a lot of those things around memorization that might be sometimes seen as a negative perception of large language models would help. It will help mitigate some of those effects. But I think we have to be mindful, we often, and this is probably a cliche statement, like with large models or with all of these models, us as AI practitioners has actually a tremendous responsibility, right, to use it in the right way, right, that benefits, for example, that kind of, and also back to the discussion on keeping humans and people at the center of everything that we do. We have to treat them with humility, but at the same time, we have to use them for the proper use, right?
Thank you. The next question is Microsoft trying to implement more AI applications into its next generation OS?
Yes, I think we have an amazing AI platform across the company that is used by all groups, right? From Bing to Office and so on and so forth. And you actually see a lot of this infusion of AI into the products as something that, like when we say when AI is successful, AI is invisible, right? And so today across Windows, in fact, if you follow the news, I'll probably not steal the thunder here, but if you look at some of the recent news, some of this already started making into the Windows 10 product on how you navigate information and so on and so forth. So it has started to happen. And so, yeah, definitely top of mind, infusing AI across all the products and all the experiences that we build. Leveraging, work by the Turing team, some of our joint work with OpenAI and so on and so forth is continuing to happen, and it's happening at an amazing pace. Yep.
Thank you for the answer. The next question has received quite many upvotes. So the person asks, AI for good aims to use AI for bettering of the planet, but yet AI model and training consumes a huge amount of energy, and that might cause byproduct and will endanger the Earth. Is it contradictory?
No, that's a good question. And if you realize recently there was a huge, I'll say active discussion in the AI community on a recent paper that was released, which is the carbon footprint from a lot of these large AI models. So that paper is actually a really good read, written by some very prominent AI researchers in the area, which is amazing. I think one of the things that we have committed to as a company is not just being carbon neutral, but to be carbon negative by, I can't remember the year, right? But we have made that public commitment. And so for all the things that we do in the company, whether it's the supply chain that we have, how we build data centers, how we operate some of the buildings globally, sustainability is always top of mind, right? And so if you read some of the news that's happened, we're building a new campus in the Redmond area. And in fact, you'll see that a lot of the energy that is used to power those buildings are coming from geothermal. And so we have a public commitment to reduce the footprint. And so when we train all these models and we leverage all these GPUs, etc., and how we can continuously strive, right, to reduce the energy footprint is top of our mind. I don't think we have solved it yet. It's something that we have to continuously pushing. But I think efforts across the company that you see us announcing almost every 3 to 6 months, some of the progress that we've made towards being carbon, not just neutral, but negative, is actually really exciting. And so I'm hopeful, right, that we'll get there. But at the same time, also making sure that we mitigate some of the effects of training some of these large models. Right?
Thank you for your answer. So due to the time constraint, we will answer one last question from the audience. So one viewer asks, data is a field for AI. What is your opinion on data trust?
Sorry, can you repeat the question again?
Sorry. So the person asks, data is a field for AI, and what is your opinion on data trust?
What do you mean by data is a field? Maybe you could elaborate on it.
So I think just now you mentioned in your slides that data is the fuel for AI.
Oh, got it. So yeah, I think data is key to everything that we do. And it's true that, when I did a mid-career switch to machine learning, and so you realize that between school and some of the challenges that we deal with and the practical commercial challenges or even sustainability challenges, you often get less data than you want. And then for a lot of the supervised approaches, you get less labeled training data that you want, right? And so one approach, of course, is you will see now globally there's a proliferation of new companies that's springing out to do data labeling, right? And so data labeling is definitely one, but we also realize that data labeling is also one of or having human labelers to annotate or label the data is also one of the inputs on some of the or wrongly labeled data, right? So that's one piece. The other thing that we've seen is, I will show you some of the examples, is we do a lot of simulation in order to generate data. Now, all the simulated and generated data are extremely clean. But more importantly, right, we have also looked at efforts to introduce noise into this to make sure that they are not as clean as it should, because otherwise they are not representative of real world data. We've been making good progress in simulation and generation of data. And so you see some of the progress that we made on synthetic data that are real, but they are real and they're as real as it approximates the real world. For example, right, one example that we did was with retail companies, where you want to be able to do that kind of no checkout experience, and you just walk in and take, right? And you see a lot of tech companies doing that. In order for you to build those kind of systems fully using computer vision, right, you will never be able to get enough people to go in and try all different combinations, different placement of shelf, different lighting condition, and so on and so forth. And so we realized that it's not just a problem with labeling of data. I think synthetic and simulated data is so important for all the applications that we do with, and we've been making tremendous progress there. And I think the third area, which is actually really exciting, in fact, I have a new book coming up in July on the topic, which is this, in this new area, pioneered by a lot of the researchers at Stanford, called weak supervision. And what weak supervision simply means is rethinking the whole paradigm of how you label data. And can you do this notion of what they call a data programming approach to getting training data, right? And so you could then apply what they call labeling function and into your training data to generate more labeled data using a library called Snorkel. And that has been actually applied at companies like Google, Apple, and all these papers are all published. And so weak supervision, I think, is a really exciting area. In fact, the professor that founded it now is a UW professor, and he started a company called Snorkel.ai that is making a lot of progress on just thinking about data, labeling data, but getting this as part of the entire machine learning life cycle, because it's not just a, like a waterfall approach from one stage to the other stage. It is iterative. And Snorkel.ai has been making tremendous progress. And hopefully, the book that we're coming up with in July, which is essentially called Practical Weak Supervision, would also help that, right? So short answer to the question is, there are companies that are spin up to do labeling. That continues to exist. Synthetic and simulated data is extremely important. And emerging field like weak supervision and related areas is going to, all this coming together is going to get us the kind of data that we need to train models, right?
Thank you for your answer. I hope our viewers can support Dr. Wee Hyong's new book coming out in July. And thank you so much for your wonderful speech just now. And yeah, I think it's now I will, so thank you again, Dr. Wee Hyong, for coming here today to give us a wonderful speech. And I believe that we have learned a lot. But now, due to time constraint, I will pass them over to the next session. Yeah.
Thank you. Thanks, Jie, for hosting the session, and thanks, Jiafei and the team for the opportunity.
Thank you, Dr. Wee. Thank you for doing this for us.